Welcome back, students. We'll be looking at section 9.2, terminology for function notations and linear functions. Let's start with looking at this image that we have right here and explain what these pieces mean. This is probably something that you either haven't ever seen or you saw it for a short time and you don't really remember anything about it. So let's talk about the different pieces. The first thing I want to point out is we have our domain value. We started learning about the domain value in the last section. And remember, our domain value is our x portion of the coordinate. Then we had our range value, which is the y portion of our coordinate. Now here comes in some new terminology for you that's going to add to what we learned in the last section. Our x value, our domain value, is what we know as our input value. Whatever we put in for x, we will get an output value. That is our y. Our x determines what the y will be, basically is what that's saying. Now, let's talk about how we would actually read this part right here. So the f and then in parentheses x is read as f of x. Or we can read it as f at x. Now, typically, or the way that I've heard it the most, is f of x. So that's the way I'm going to read it throughout our videos on this section, but you can say either. Now, f of x is another name for y. So looking at this example, I'll explain what I mean by that. Y equals 2x plus 5 is the same as saying f of x equals 2x plus 5. So what I want to basically try to emphasize, and hopefully you will remember this because it's very important for this section, is this right here is just another way of displaying y. They are the exact same thing. It's just y written in a different format. Okay, so f of x, this whole thing is y, and y is this whole thing. So that's why we're able to switch them out interchangeably, because they are the same thing. It's as though a number has two different costumes that it can put on depending on what situation it's in, okay? But they are the same person within that costume, those two different costumes. All right, so let's talk about how we would evaluate a function. So number one says, let f of x equal 6x minus 2. Find the value of function f for the value of x. All right, if x equals negative 2, and you're probably thinking, what in the world are they asking me to do? I don't understand any of this terminology. So let's go through what they're saying. So let's talk first about the equation. The equation f of x is the same as saying y equals 6x minus 2, okay? They're the exact same equation, it's just a different way of writing the y value. Now, if you saw this version and they said, solve for y if x equals negative 2. Well, you'd say, oh, okay, well, I'm going to say 6 times negative 2 minus 2, and then I would solve for y. You would substitute that x in. Well, guess what? We're going to do the exact same thing with these functions. So over here on the right, we had f of x equals 6x minus 2. But they said, well, what if x is negative 2? So I'm going to replace all of my x's with negative 2. And it'll look like this. Very similar to this right here, right? The only thing is we have f of -2 instead of a y, but it's the same thing. All right, so let's go ahead and solve this. So f of -2 equals 6 times -2 is -12 minus 2. I'm going to adjust that to the keep it change. And we get f of -2 equals -14. So that is basically the same as saying y equals -14, because remember, f of x is the same as y. Now what they want us to do is to write our answer as an ordered pair. So I'm going to take my x value that they gave us, use that for my x. The f of -2 value that we found is our y value. So I'm going to put -14 here, and that's our answer. We have a coordinate. That's what the function is doing. It's helping us find a coordinate, okay? Now let's look at number 2. We have f of x equals 6x minus 2. It's the same equation. Find the value of function f for the value of x if x equals 5. All right, so now we have a new value for x. We're going to go through the same process. So again, remember, f of x equals 6x minus 2 is the same as y equals 6x minus 2. So all we're going to do over here on the right is replace our x with 5 now to find a new y, okay? We're looking for a new coordinate. So let's see, f of 5 equals 30 minus 2. So f of 5 equals 28. So that tells me my y portion of my value is 28, okay? So that I'm going to write my ordered pair. Our x now is 5 because that's what they gave us. They had changed it. So now our y is 28. Now, I want to go back up here to something I had said earlier. Remember, I said our x value is our input. That's what we plug in. What we get is our output. What the number that it gives us after we solve the problem is our output, and that is our y value. Well, look what we're doing right here. We're inputting an x value, our 5, to get a result, an output, the y, okay? So that's why they call them inputs and outputs. Now let's look at number 3. We have g of x equals -x squared plus 5x minus 3. And you're probably saying, wait, we just learned f of x. Now we gotta learn g of x. They don't work any differently. They work the same way. It's just sometimes you'll have more than one function and you need a way to differentiate between those. So what they did was they just give a different starting letter to differentiate one function from the other. They work exactly the same. So we would just read this one instead of an f, we would say g of x. All right, so we've got a new equation here and they tell us our x is 2. So I'm going to replace all of my x's with 2. 2 and 2. Now, one thing that I want to point out is our -x squared. Make sure that when you substitute in a number, you write it in this way. That 2 is in a parentheses. Remember, that's why we always substitute with a parentheses. That negative is going to be outside that parentheses because it was a part of the original problem. All right, so let's go through and solve this. G of 2 equals 2 squared is 4 plus 10 minus 3. I'm going to rewrite this. That becomes -4 plus 10 minus 3. That's why that negative outside the parentheses is important, because it completely changed the sign of our number that we squared. And if we don't have that in the proper location, it's going to mess up what sign we have with our number. So g of 2 equals -4 plus 10 is 6. And then we have the minus 3. So g of 2 equals 3. So that means our y value is 3. So if our input, our x value was 2, our output value, our result, our y value is 3. So our x determined that our y value would be 3. Now let's look at number 4. We have let g of x equal negative x squared plus 5x minus 3. Okay, we have the same equation. Find the value of function g for the value of x if x is negative 2. Okay, so instead of 2 this time, they want us to use a negative 2. So I'm going to plug in everywhere that I have an x, a negative 2. So I have g of negative 2 equals negative 2 squared is a positive 4. 5 times negative 2 is a negative 10. And I'm going to go ahead and change my minus 3 with the keep it change just so the next couple of steps will be simpler. So I get g of negative 2 equals negative 4 plus negative 10 plus negative 3. So g of negative 2 equals negative 4 plus negative 10 is negative 14. And I still have my plus negative 3. So g of negative 2 equals negative 17. So our y value is negative 17. Now I'm going to write our order pair. If our input is negative 2, if our x value is negative 2, then our output, our result, will be negative 17. So you can see how your input, if it changes, then your output will change. That's why they say the x is the independent and the y is the dependent. The y value is dependent on what we plug in for our x value. Now let's look at number 5. Let h of x equal 2x plus 3. Find and simplify h of a plus 1. So now we've got, instead of just a number that we're plugging in, we have a variable with it. Doesn't change what we do. We're still going to plug it in and solve. If we can't solve completely, then we just simplify as far as we can. So let's look at this one. We're going to put in the a plus 1 right here. Or here, no, actually that's the original input, which was x. Trying to get my pen here. There we go. Now we're going to put in the a plus 1. Because we're replacing all the x's with the value a plus 1. So I have h of a plus 1 equals, I'm going to distribute 2a plus 2 plus 3. So I have h of a plus 1 equals 2a, that 2 plus 3 is plus 5. We can't go any further, so that is our answer. Okay, so our y value that time would be 2a plus 5. So you would write your x value is a plus 1. Your y value is 2a plus 5. Looks a little weird for a coordinate or an ordered pair, but that's how you would actually list that one. Number 6, let f of x equal 3x minus 7. Find f of 3. So if our x value is 3, I'm going to replace all my x's with that 3. So I have f of 3 equals 9 minus 7, which f of 3 equals 2. So my coordinate would be 3, 2. Number 7, let f of x equal 3x minus 7. Same one, but this time it says find f of x equals negative 1. All right, I want to point out something very, very important, because students oftentimes get confused or they forget the difference between these two. This one has find f of 3, okay? They replaced the x on this one. That's why we plug in the 3 for that x value, because it's where the x was right here, okay? On number 7, what they replaced was the y value Okay, they replaced this one this time. Notice the -1 is here. It's not here. So that changes things. So on number 7, what we have to replace is our y value, which is this whole thing right here. So this whole thing becomes -1. We're not plugging in for our x in this one. So be very, very careful. If the number is not in the x location, you're not replacing x. If it's in this location right here, that's when you're going to replace this whole thing with this number, because that is our y, okay? So let me go through that again just one more time, because I want to make sure that's really clear and I don't confuse you. I want you to notice the difference between the two. So this one replaced the x value with a 3. This one did not replace the x value. What they replaced was this whole thing right here, which represents our y, remember? Because f of x equals y. So what they're doing when they write it in this manner is they're saying replace your y with this value. Well, our y is this whole thing, right? So we're going to replace this whole thing with the number that they gave us, the -1. We're not replacing x in this one. We're replacing our y value, the f of x. So now let's go through and solve. We have -1 equals 3x minus 7. So what I need to do is add 7 to both sides, because in this particular example, we're finding our x. We know our output. We don't know what was put in to get that output, basically. So I have 6 equals 3x plus 0. So 3x equals 6. Divide both sides by 3. And I get x equals 2. All right, so our ordered pair for this one is going to be 2, -1, because they gave us our y value here. That was the -1, and we were looking for our x, which is the 2. So 2 is our input. If we put 2 in this function, we get an output of -1, our output of y, which is -1. All right, let's look at number 8. This one has the function equals, and then it has a list of coordinates of ordered pairs. It has 8, 0, 5, 4, 3, 9. And they say find f of 3. So remember that 3 is in the location where x normally is. So what they're saying is, if our x is 3, what is our y? Well, if x is 3, our y is 9. And that's what we would put there. The next one says find f of x equals 4. So what they replaced was the y. And they're saying if our y is 4, what is our x? Well, our x would be 5. Number 9. They replaced the x with a 3. So what is our y if our x is 3? Well, remember when we have our little bubbles, first bubble is always our x, the second one is our y, because this is our domain and this is our range. Okay, so if our x is 3, what is our y? Well, our y is -1. The next one says find f of x equals 3. All right, so this time they didn't replace the x, they replaced the y. So if our y is 3, what is our x? It's 9. 10. Find f of 3. So again, they replaced the x with 3. And they say, well, if our x is 3, what is our y? Our y is -2. Find f of x equals 3. This time they replaced the y and said it's 3. Well, if y is 3, what is our x? It's 5. Hopefully that makes more sense now. I wanted to give you several examples of that just to make sure you fully understood the difference between the two and what they're asking. All right, so now is giving you an example of, well, what if we have a graph and they're asking us these particular questions? Find f of 2. So again, they replace the x with a 2, and they're saying, well, if our x is 2, what is our y? So what I need to do is go over to the 2. Our 2 is right here. Well, where do I need to go from there, up or down, until I hit a coordinate? I go down to here. So if our x is 2, our y is going to be the y portion of this particular coordinate, which is -3. The next one says, well, f of x equals 3. What is our x? So this is our y, remember. So I'm going to go where my y is a 3. And then I've got to go left or right to find my coordinate that it's going to hit. Well, I have to go left to hit this one right here. So if my y is 3, what is my x? Well, my x is -4, part of that coordinate, because that coordinate is -4, 3. The other one that we had found was 3, -3. So all we're doing is we're finding the second part of the coordinate based on one part of it. Number 12, what if we have a line? How does that change things, or does it change things? Find f of 1. So again, this is our x. They replace the x. Well, if our x is a 1, where do I go up or down to find my y? If I go up, I hit it right here. And that's at 4. So if f is 1, if our x value is 1, then our y part of that coordinate is 4. Should have done that in green. Let me replace that just for consistency, so we don't get confused when we look back at it. Now we'll do blue. All right, the next one says find f of x if it equals -1. So what they're saying is this is our y. If our y is -1, which is right here, where do I go, left or right, to find my x value? I'm going to go to the left, and I hit the line right here. So that means my x part of the coordinate is -2. Writing equations using function notation. Step 1, solve the equation for y if the equation is not in the proper form. Step 2, replace y with f of x to write the equation in function notation. And then step 3, depending on the equation, either simplify or solve the equation. So step 1 on our example has 2x minus 5y equals 4. Now remember, step 1 says solve it for y. We've been doing that. So let's go ahead and do that fairly quickly. So I'm going to subtract 2x from both sides. Think getting it in slope-intercept form. Same thing. So I'm going to get 0 minus 5y equals -2x plus 4. So that's -5y equals -2x plus 4. Divide everything by that -5. And I get y equals 2/5 x minus 4/5. And that is our equation of a line, and we've simplified it into graphing form, basically. Now what they said do in step 2 is replace that y with f of x and write the equation in function notation. Okay, so I'm going to rewrite it and replacing that y because they mean the same thing. So now this is our function that we're going to be working with. So I'm going to rewrite it over here. Okay, and they say solve it. What if x is -1? What would our other half of our function be, the y portion? So I'm going to plug that in. So f of -1 equals 2/5 times -1, because I'm replacing my x with that, minus 4/5. All right, we get f of -1. 2/5 times -1 is a -2/5. I'm going to go ahead and change this to keep it change. So this becomes -4/5 like this. Now we're going to add them together. And I get -6/5. Okay. So our result is -6/5. Well, we still need to write our ordered pair for our answer. So remember, our x value was -1. That's what they gave us. And we just found our y value is -6/5. And that's our answer. All right, linear and constant functions. So linear equation can be written as a linear function. Domain, the -infinity to the +infinity, unless specifically specified as something else. The range is the same thing unless specifically specified as something else. Okay, so your range will always be this, your domain will always be this, unless they tell you it's something different. Over here, we have y equals mx plus b is exactly the same as f of x equals mx plus b. The only thing that they changed was they switched out the y for the f of x so that it would be a function. Horizontal line equation can be written as a constant function. So for a horizontal line, the domain would still be -infinity to +infinity. It goes left and right infinitely. There's no change. Because remember, horizontal line is flat. The range is going to be whatever y or f of x equals. Remember, it's going to have a limit on height or depth because a horizontal line does not have a rise. So it's only going to have one number for your y or your f of x. So for example, right here, y equals 2 is the same as saying f of x equals 2. Remember, this is your y in this location. So your domain, it's a horizontal line, so it never ends. It goes left and right infinitely. But our range is limited because it only crosses our y. The only height that it has is at 2. Every y value of that horizontal line is always going to be 2. So that's why it looks different than the previous example. Okay. Now, graphing linear and constant functions. Remember, this is the same as saying y equals 3/4 x minus 2, okay? That doesn't change how we graph, or 3/4, let me write it correctly. It doesn't change how we graph it. We're still going to graph it like a line. So I have my starting point of 0, -2, and I have my slope of 3/4. So I'm going to go to 0, -2, put my first coordinate, and then use my slope to find my second one. So I'm going to go up 3 over 2, and I have my second coordinate. Now I'm going to connect so we have a line. But based on our graph, they want us to list our domain and our range. Well, remember what it said up here. Unless specifically specified as something else, you're going to have this situation here. Well, when is it specifically mentioned as something else? Well, a horizontal line is one way, okay? All right, so let's look at this. We have our domain. Does it ever stop going left or right? No. It goes infinitely, -infinity, +infinity. Well, what about our range? Does it ever stop going up or down? No. And this just shows you that what I mentioned earlier in our notes holds true. All right, well, g of x equals 3. Let's think this through. I know that g of x equals y. Whatever is on this side is my y value. So this 3 is my y. This is the same as saying y equals 3. If we had y equals 3, that told me we had a horizontal line because we didn't have an x there. We only had the y value of 3, which meant our x value could change. It could be any number, but our y value had to always be 3. That tells me I have a horizontal line at 3. So I'm going to draw that horizontal line. Well, again, up here, we learned that if we have a horizontal line, our domain, it never stops going left and right. But our range was only one number. It was where it crossed the y-axis. It was the value that our y always is with a horizontal line. So the way we're going to write our domain will be negative infinity to positive infinity. All right, so we figured out that our domain is negative infinity to positive infinity. Let's talk about our range. Our range is going to be just the number 3. And the reason is because it doesn't change from 3. It doesn't go up, it doesn't go down. It's always 3 for our y value. But how do we enclose our 3? We're not going to use parentheses or brackets for this one. We actually use our braces. And this just says the only solution for y is a 3. Now let's read our verse. Just as our bodies have many parts and each part has a special function, so it is with Christ's body. We are many parts of one body and we all belong to each other. Romans 12, 4-5. All right, guys, I hope you're having a great day. I'll see you in the next video. Bye.